we do this. Something like that. Right, you have one box there, so this, crack this like this. No friction, so don't put friction. Fn, Fg, tension. This, of course, is mg cos theta. This is mg sine theta. And then this one is m2g and tension also. Because this is M and this is M2. Remember, F sub G is mass times gravity. That's the definition. On your formula sheet, that is called W, weight. Okay? If the box on the incline is 5, what will be the mass of the hanging box? So basically, we're going to use the force diagrams. We're going to do some of the force statements. So I say sum of the forces in the x is 0, sum of the forces in the y is 0, and I'll do this in red so we can see sum of the forces in the y is 0. Have I just lost my mind? Why did I do y twice? Good. I'll go ahead and highlight this in red so we can see it's this box right there. Okay, that's the other one. Yeah. You mean if you don't do another one of these? Yeah, you have to do it all. It's very important to the problem, and you'll see why in just a second. In the x, I have t minus mg sine theta equals 0. In the y, I have fn minus mg cos theta equals 0. What? It's F sub G. F sub G is mass times gravity. So mg is F sub G. Does that make sense? It's like what they're equivalent. It's on your formula sheet already. Look for weight. Weight is mass times gravity. Yes?
Why didn't you do mg sine minus tension? You can do it either way, or it just has to be the other?
Yeah, whatever. It doesn't matter because it's good. You see what it's going to do.
Yeah.
Now, make sure you stay consistent. You know what I mean? Like, don't make up positive on half the problem and then make a negative on the other half, because you're going to screw yourself up. But if you make up positive for everything, that's fine. Down positive for everything, that's fine. So then we say here, Fn is equal to mg cos theta. And then, of course, over here in the red, we say T is equal to m2g. Notice I've kept them separate by the labeling. Okay? Now, this is the same T, though, so I can take this and stick it in there. So that gives me, I'll do the color coordination, m2g is equal to mg sine theta. So I can cancel the g, and that's it. That's my answer. If the mass on the incline is 5 kilograms, the mass of the hanging masses would be the 5 kilograms times sine of theta. Theta is 30 degrees, so that's going to be 0.5. So the hanging mass is 2.5 kilograms. I feel like this is reasonable. See how this one's just a touch easier than the other one was? Right? Part 1B was more difficult. This is reasonable. 2B seems reasonable. Yes?
Why isn't it T2? And why don't they have different tensions?
Because that's the same strength. Now, remember what I'm sort of preparing you for the future. When that pulley has mass and friction, then they will be different. So in the future, when we start dealing with that pulley like a real object with mass, then does it make sense to you that when you pull on the string is doing two things. It's pulling the other string and it's rotating the pulley. See, so that's, in the future, that will take place. Yeah, Ken?
Where did you get?
What's the sine of 30 degrees? 0.5. Okay, questions on these two first parts? Any other questions? Good questions so far?
Can you just add the two?
I just put all the force diagrams together and get what I want, right? It asks for M2, so I have to, but I don't know tension. Oh, look, I can set these two equal to each other. Yeah?
What if it wasn't like times of the same string like he told Justin, that since it was the same string, it was T and T and not T1, T2. What if it was two different strings?
We were not ready for that.
Oh.
It will be, but we're not ready yet. And I will show you how to do that when we get to that. Other questions? Yeah.
When do you label the FG, MG?
FG is MG. It's the same thing. It's like a name for this. It's on your formula sheet. Look on your formula sheet and find weight. No, it doesn't matter. If you put FG, if you put W cosine theta, if you put M times G, it's fine. Just please remember, this is F sub G, subscript G. It is not F times G. Okay, this is force of gravity, right? Just like force of normal or force of friction, right? F sub F, all these things. This is mass times gravity. These are two distinct things. This is one thing as a label. All right, other questions? Alrighty, we're going to move on. Okay, if the hanging box is the same mass as the inclined box, what mu is needed? So now we have to say, is this going to move? Yes, this is going to move? No, right? Keep the boxes from moving. Subtle clues like this will help us figure out how to solve the problem, right? So we're going to keep it from moving. So most of our force diagrams are pretty much the same. So then my statements should be pretty much the same. Again, uphill is going to be T. Downhill, so I'm just going to go ahead and say equals, is equal to mg sine theta. And, oh, you know what? Let me do it right. Otherwise, people are going to freak out. I won't cut shortcuts. Sum of the forces in the x is 0. Sum of forces in the y is 0. Sum of the forces in the y is 0. So again, we have t minus, or can I go ahead and say equals? Is that okay? Okay. T equals mg sine theta. Then this one, Fn equals mg cos theta. And this one, t is equal to m2g. Did I write those right? Is anything missing? Oh, something's missing. What's that? What does that mean? If there's mu, what force has to be in this equation? F sub F. Where should it go? Y, or X? In the X. And does it go with T or against T? So then I can just go plus F sub F. So not the end of the world, just a little bit of an addition there. Okay, and we need mu. So I'm going to go ahead and solve this for F sub F. F sub F is equal to T minus mg sine theta. We know T is m2g. So that means F sub F is m2g minus mg sine theta. And of course, what do we know F sub F to equal? Yeah, it actually equals, mu F sub n. And F sub n's right here, so we're going to substitute that in. And we get mu, actually, you know what? Let me go ahead and divide both sides by it, make life easier first. So mu is going to be equal to m2g minus mg sine theta over F sub n, which is mg cos theta. So if the hanging box is the same mass as the inclined box, that means m is equal to m2, doesn't it? And that means I can cancel out mg from everything. And so I get 1 minus sine theta over cos theta. And then that becomes 0.5 divided by 0.866. So that's 0.577. That's what mu has to be to keep it there. Questions on that one? Yeah. I heard nothing after.
Can you explain why you needed cost them?
Oh, I didn't need to. I'm just lazy and I want math to do my work for me. So rather than plugging all of those MGs into my calculator, I'd rather just cancel them out. Do you see how they cancel out?
No.
You see how there's an MG in every single term? So then, therefore, it cancels out. No? If not, look at this. A equals, let's say, 2A plus 2B, not 2A, 2C plus 2B over 2D. See? I can say 2 times C plus B over 2D, and that cancels out. Yeah, it was, but remember they told us in the problem, same mass. Hanging is the same mass as the incline. So that's why we're allowed to do that. Yeah. Okay, questions? Yeah.
The way I did it, I just made tension equal to friction, and when I did all the work, I got the same answer, but would I have to show that work to get all the points?
Tension equals friction. Tension doesn't equal friction.
Okay.
So I don't know how you got the right answer, but that.
Because I ended up with mg sine 30 over mg cos 30, and when I divided them, I got 0.577.
Because sine 30 over cos 30 is tan theta. Is it just lucky that it comes out that way? That's slightly different.
Oh.
So the answer, because this is 0.577367, and if you do tan theta, it's 0.577350. So you would lose credit for all of this and maybe get credit for the answer. That's it. Yeah. But do you see why that's wrong?
Yeah.
Yeah, okay, cool. All right, finally, we go on. I'm going to do this in a different color so we don't get too, and keep it separate. If the hanging box is twice the mass of the incline box, so that means M2 is 2 times M1. Does that make sense to everyone? Okay. What mu allows the box to fall at 1 meter? This is x. This is t. What was the original velocity of something that just starts moving? V0 is 0, so we just find acceleration. X equals V0t plus 1/2 at squared. A is equal to 2x over t squared. So 2 divided by 0.77 squared gives me 3.37. So this is 3.37 meters per second squared. That's the acceleration that we want. We want the net acceleration to be that. So now this is different than the others. Because A, B, and C, box A, B, and C, the thing wasn't moving. Now it's moving. So we have to do this. Basically, it's the same sort of stuff, except instead of in this one and in this one, it's MA. So the sum of the forces in the X are not 0 anymore. They're MA. Sum of the forces in the Y, is that MA? When is the sum of the forces in the Y MA? Yeah, like it'd have to be flying up. Right? It has to be moving up. So almost never. And then sum of the forces in the Y is MA for the second one, right? Because that block is moving down. Okay? So then, I'm going to say T minus mg sine theta minus F sub F is equal to MA. And of course, F sub N is still just going to equal mg cos theta. And then the last one is going to be T, just kidding. Who wins, tension or gravity? Gravity. Oh, good job. I didn't have to draw it out. That's nice. M2G minus T equals M2A. Please notice Please notice, what mass did I use here in the sum for the second one? M2. Here I use M1, here I use M2. That should be M2A. Do you see why? Yeah, it's a different mass. These two are both M, but this one's M2. Okay? Now it's alphabet soup. Just solve it. Right? The whole thing is you're looking for mu. Where is mu? It's inside of here. I'm gonna do this right away. T is equal to M2G minus M2A. And that's going to allow me to substitute that in here. So I'm going to substitute like that first. So I'm going to get M2G minus M2A minus MG sine theta minus, instead of FF, I'm going to put mu Fn equals MA. And then you can see now I'm going to sub this in here. And I'm going to do a bunch of algebra crap all at once. Wave my magic wand and get mu is equal to M2G minus M2A minus MG sine theta minus MA all over Fn. And what is Fn? It's mg cos theta. What's that? Because I move this one over here, move this one over here. But I like how you're paying attention because I have been known to make mistakes. Okay, so no. Little like mouse running on a wheel. That'd be a cool Halloween costume. Like open it up and have like an LCD screen or something in there. Okay, the cool thing is, do you remember when we said that M2 is 2M1? So if I take that, do you see I can do this? Wherever I see an M2, I can put a 2M1. Right? And if I do that, that lets me cancel out all of the M's.
Yeah, that's what I was going to ask right now.
Yeah.
I was going to ask if you were able to cancel the M's.
Yep, all of the M's cancel. You can't cancel out all the G's, but all the M's cancel. And so then, if you plug this into your calculator, you get you get 2 times 9.8 minus 2 times the acceleration, which is 3.37, right here, minus g sine theta, 9.8, times the sine of 30. Was it 30? I think it was 30, right? Minus a, which is 3.37. All of that divided by 9.8